Hi, this class we are going to talk about the problems in magnetic Lorentz force. That means when you place a charged particle in a uniform magnetic field, it experiences a force. That is called a magnetic Lorentz force. Say for example, here we have a charge plus q, x, y, z. Along the direction of z axis, magnetic field is passing through. In YZ plane, the particle is moving, the charged particle is moving in YZ plane, making an angle theta with respect to Z axis, that is magnetic field axis. Then force F proportional to two factors. It is directly proportional to the magnetic field of induction or magnetic flux density V, and it is proportional to component of velocity perpendicular to magnetic field. Component of velocity perpendicular to magnetic field. The magnetic field is here. Here you have put theta. So this will be B sin cos theta and this will be B sin theta. Suppose if you put theta here, this will become B cos theta and this will become B sin theta. Most of the students are having wrong notation. Horizontal direction is cos component, vertical direction is sin component. It is not like that. It depends upon theta where you are taking. If you are taking theta with respect to horizontal, then this is horizontal component V cos theta. But in our case, here we have taken theta, so it should be V cos theta along Z axis and V sin theta along Y axis. So V sin theta, or F is equal to constant Q B V sin theta. Sin theta means you can use as a vector product. So F vector is equal to Q into V cross V. Direction of force. So direction of force will be away. Suppose minus Q charge you are taking means it is inwards. If you are taking theta as 90, particle is moving in this direction. Theta is 90. Then Fleming's left hand rule. Fleming's left hand rule. Extend the first three fingers of the left hand in three mutually perpendicular direction. Forefinger represents direction of magnetic field. Middle finger represents direction of movement of the conductor. Conductor means the charged particle which is moving. Then thumb represents direction of force. Okay. So based on this, we will do the problems. Most of the problems, B given, Q given, B given, calculate force. Or force, velocity, B given, calculate the charge. But calculate the charge will be 99%, it will not be asked because electron, proton, alpha particle, like that only questions will be asked. So all these things, you know the charge value. So calculate B, calculate B, calculate F. Depending upon the problem, we have to solve. Okay, so this is the basic information regarding the magnetic Lorentz force. So next we will see the problems related with this. First problem, a proton enters a magnetic field of flux density 2.5 Tesla with a velocity of 1.5 into 10 power 7 meter per second at an angle of 30°. Find the force on the proton. First problem, F is equal to BQB sin theta. Value of B, magnetic induction or magnetic flux density 2.5 Tesla. Proton, charge of a proton and charge of an electron both are same. 1.6 into 10 power minus 19. Moving with a velocity of 1.5 into 10 power 7 meter per second. Moving perpendicular. Moving perpendicular. Enters a magnetic field. No, perpendicular is not. Moving at an angle of 30 degrees they have given with respect to the magnetic field. So F will be 2.5 into 1.6 into 1.5. 10 power minus 19, 10 power 7 is 10 power minus 12. Sin 30 is off. Simplify this, you will get 3 into 10 power minus 12 Newton. 3 into 10 power minus 12 Newton. Straight problem. Okay. Second one. An alpha particle is projected vertically upward with a speed of 3 into 10 power 4 kilometer per second in a region where magnetic flux density or magnetic field of 1 Tesla exists in the direction south to north. Find the magnetic force. South to north. F is equal to BQB sin theta. East, west, north, south. Okay. Alpha particle. So Q is equal to Ne. Alpha particle is 2He4. So that is 2 into 1.6 10 power minus 19 Q. B will be 1 Tesla. V will be 3 into 10 power 7 and theta is 90. These are the data. Substitute. Therefore, F is equal to B. Q is 2 into 1.6 10 power minus 19. V is 3 into 10 power 7 sin 90. 2 into 1.6, 3.2, 3.2 into 3, 9.6, 10 power minus 19 plus 7, 10 power minus 12, sin 90 is 1 Newton. We have to calculate the direction of force using Fleming's left-hand rule. Magnetic field along northwards. So this is B given. Velocity will be, what is the direction given? south to north. Alpha particle projected vertically upward with a speed of 3 into 10 power 4. So velocity upward. Okay. Next, what is the direction of force? This is the direction of force. These two are perpendicular. Magnetic field is placed perpendicular is a question. The direction of force will be according to Fleming's left hand rule. This is four-finger direction of magnetic field. And this is force. These two are perpendicular. Particle is moving vertically upward. Vertically upward. Same concept. Third problem. An electron is moving towards northwards with a velocity of 3 into 10 power 7 meter per second in a uniform magnetic field of 10 Tesla. Magnetic field is given, velocity is given. Magnetic field directed eastwards. Find the magnitude and direction of force. First magnitude we will calculate. B, Q, V, theta. Theta here perpendicular, so 90. Velocity 3 into 10 power 4 kilometer per second. 3 into 10 power 4. Kilometer is 10 power 3. So 3 into 10 power 7 meter per second. Charge. No, theta 90. Q is electron only. 1.6 10 power minus 19. Velocity is 3 into 10 power 7. Directly they have given. B value 10 Tesla. Therefore, F is equal to BQV sin 90. B is 10 Tesla. Charge 1.6 10 power minus 19. Velocity 3 into 10 power 7. So force will be 3 into 1.6, 4.8, 10 power 7, 10 power 8, 10 power minus 19, 10 power minus 11 Newton. Now direction. Same. East, west, north, south. Along east direction is B. Okay. Next. Velocity will be along north. This is velocity. So definitely the force will be vertically upwards. Like this. Like this. Towards east. So this should be vertically upwards. Force. Basic information based on Fleming's left hand rule. This is 90 degree between these two. Of course, when you are drawing the diagram on the board, it is a two-dimensional one. Exactly, we cannot picturize. Simple. In space, you extend like this, like this. Now you can see all the three mutually perpendicular directions. Okay, so this is the third problem. Fourth one. A positive charge of 1.5 microcoulomb is moving with a speed of 2 into 10 power 6 meter per second along the positive x-axis. Magnetic field B is equal to 0.2 J plus 0.4 K Tesla acts in space. Find the magnetic force acting on the charge. BQV. What are the data given? B is 0.2 J plus 0.4 K. Q charge, positive charge of 1.5 microcoulomb. 1.5 microcoulomb, 10 power minus 6 coulomb, with a velocity 2 into 10 power 6. Meter per second, of course. What is the formula? F is equal to, since it is given I cross J cross K, we have to use the basic formula. F is equal to Q into V cross V. Q 1.5 into 10 power minus 6. V 2 into 10 power 6. Acting along positive x-axis. This is V. I cap cross B is 0.2 J plus 0.4 K. Excellent problem this is. It is not the straight one. So F is equal to 2 into 1.5 into 10 power minus 6 into 2 into 10 power 6 0.2 I cross J plus 0.4, 2 into 10 power 6 you have taken out common. So 0.4 into I cross K. You know very well, in vector product properties, IJK, you are taking in clockwise, then I cross J will be K. I cross J will be K. Okay. Here I cross K. I cross K. I after J only you are getting K, but you are skipping J here. I cross K, another direction J will come, but you are skipping J in between, so we have to put minus sign. Okay, it is a product of property of vector product. Therefore, F is equal to 1.5 into 2, 3. 10 power minus 6, 10 power 6 cancels. 0.2 I cross J is K. I cross K is minus J. minus 4.4 J. So F is equal to 0.6 K minus 1.2 J. Clear? So it is a slightly different problem. Directly B is not given. B exists in space with two different directions, J and K. Then accordingly we have to substitute because the formula itself is a vector product. Sir, what happens to sin theta? We have not gone to the expansion at all. If we expand, sin theta will come. Here we have not expanded at all. Directly cross product we have calculated. So sin theta has got no effect here. Okay, fine. Next, fifth problem. A 5 MeV proton is falling vertically downwards through a region of magnetic field 1.5 Tesla, acting horizontally from south to north, horizontally. Here they have given, find the magnitude and direction of force. 5 MeV proton. Kinetic energy, 5 MeV proton moving. 5 MeV. Moving means that energy is equal to kinetic energy. So I can write half mv square is 5 million electron volt. Million is 10 power 6. Electron volt is 1.6 10 power minus 19. So V square is equal to 5 into 1.668, 10 power 6, 10 power minus 19, 10 power minus 13. These two also will go that side by M. 16 into 10 power minus 13 by mass. Mass of proton. Proton mass is nearly 1.6 10 power minus 27. They are given in the problem itself. 1.6 into 10 power minus 27. Actual value 1.67 10 power minus 27 kilogram. But problem they have given here is 1.6 10 power minus 27 for a simple reason to cancel. That's all. V square is equal to 16 by 1.6, nearly 10 times. 10 power minus 13 plus 27, 10 power 14. Take square root. Root of 10 into 10 power 14. Root 10 is 3.16. Root 14 is 10 power 7. This is velocity. Previous problem, magnetic induction directly not given. Using vector product we have calculated. Here velocity is not given directly. Kinetic energy versus energy possessed by the proton. Using that we have to calculate velocity. So we have calculated 3.16 into 10 power 7. Now direct problem. What? F is equal to BQV sin theta. So BQV. What is B value given? 1.5 Tesla. Q 1.6 10 power minus 19 coulomb. Velocity we have calculated 3.16 into 10 power 7 meter per second. Theta moving perpendicular theta 90 degree. Therefore, F is equal to B value 1.5. Next, Q is 1.6 10 power minus 19. Velocity 3.16 10 power 7 meter. You are getting the answer 7.58 into 10 power minus 12. Newton. Very, very, very small force. So small. Direction of magnetic force you have to calculate. This is south to north. South to north means it should be along eastward. South to north. Positively charged particle. According to Fleming's left-hand rule, four-finger direction of magnetic field. Four-finger direction of magnetic field. Then force will be inverse. Inverse means like this. Eastward. F along east. By Fleming's left-hand. Correct, Amma? Previous problem, velocity is that magnetic field or magnetic flux density directly not given. In this problem, velocity we have to calculate and then substitute. Okay. Next, sixth problem. Copper has 8 into 10 power 28 electrons per cubic meter. That means number of electrons given. Copper wire length 1 meter, cross sectional area 8 into 10 power minus 6 meter square. Length 1 meter, area 8 into 10 power minus 6 meter square. Okay. Then number of electrons 8 into 10 power 28 per meter cube. Charge is not given directly. Simple. From this, we have to calculate the total charge. Remaining as it is. What we have to calculate? Acting right angle to be theta 90. B value given 5 into 10 power minus 3 Tesla. Then what you have to calculate? Force 8 into 10 power minus 2 Newton. Force also given. Calculate drift velocity. Velocity in which the electrons are moving in the conductor. That is called a charge movement. Charge movement means current. So that velocity is called drift velocity. Formula F is equal to BQV sin theta, in our case BD. So here theta 90, force 8 into 10 power minus 12 minus 2, B given. Q we have to calculate. Q is Ne, actually number of electrons into charge. But copper wire length and area given. So we have to multiply by volume of the wire. If length and area not given means we can take it as 1. Directly we can substitute. Here area and length given. Number of electrons 8 into 10 power 28. Charge 1.6 10 power minus 19. Volume A into L. That is 1 into 8 into 10 power minus 6. 64 into 1.6. 10 power minus 19 minus 6 minus 25 into 10 power 28, 10 power 3. 102.4 into 10 power 3 coulomb. For the given data, we can work out the problem. That is different. But unfortunately, logically, this problem is wrong. IIT, JEE or NEET, logically, what is wrong in this problem, they will ask. Because Coulomb's inverse square law we have studied. In Coulomb's inverse square law, 1 coulomb of charge experience a force of 9 into 10 power 9 Newton. 1 coulomb charge. 9 into 10 power 9 Newton force. One body only should carry the charge. Then equate that force to the charge. 9 into 10 power 9 equated to mg, the weight of the charge. G nearly 10 you take. So approximately mass is 9 into 10 power 8 kilogram. This is for 1 coulomb. 1 coulomb charge means the body should possess a mass of 10 power 8 kilogram nearly. St. Thomas mountain mass. So practically not possible. That much amount of mass carrying a charge means it is absurd. Here you are getting 102.4 into 10 power 3. So nearly 10 power 5 coulomb you are getting. Practically it will not come. For the problem it can work out. No problem. Okay. So VD, therefore velocity will be F by BQ sin theta. F 8 into 10 power minus 2. B value 5 into 10 power minus 3. Q 102.4 into 10 power 3 sin theta 90 degree. Moving perpendicular. So 90. What is the velocity? 1.51 into 10 power minus 4. See? Absurd answer I told we are getting for charge. It is reflected in velocity. 1.5 10 power minus 4 meter per second is the velocity less than your velocity. When you move from one point to another point, 1 meter per second, you yourself can move. You see the velocity of electron 10 power minus 4 meter per second. It can never happen. Okay. Fine. Next, seventh problem. An electron moving with a velocity of 5 into 10 power 7 meter per second centers a magnetic field of 1 Weber per meter square at an angle of 30 degree. Calculate the force. Straight problem. Magnetic Lorentz force F is equal to BQV sin theta. Given B is equal to 1 Weber per meter square. Electron charge is 1.6 10 power minus 19. Moving with a velocity of 5 into 10 power 7 meter per second at an angle of 30 degrees with the horizontal. So sin 30. 5 into 6 is 8. 10 power minus 19, 10 power 7, 10 power minus 12. Sin 30 is half. So you will get 4 into 10 power minus 12 Newton. Straight circuit. Okay. Next. Eighth problem. An alpha particle of mass 6.65 into 10 power minus 27 kilogram, charged twice that of an electron, but of positive sign, travels at right angles to a magnetic field of speed 6 into 10 power 5 meter per second. Magnetic field 0.2 Tesla. Calculate the force and the acceleration of the alpha particle. Force F is equal to BQB sin theta. The data BQB theta. B is 0.2. Q is alpha particle. NE, that is 2E. 2 into 1.6 10 power minus 19. Velocity given 6 into 10 power 5 meter per second. Theta value not given, moving perpendicular. Not given means moving perpendicular, so theta 90. So F is equal to D.2 Q 3.2 into 10 power minus 19 into velocity 6 into 10 power 5 theta sin theta 1. So F is equal to value 4.8 into 10 power minus 12. 3.2, 32 into 2, 64, 64 into 6. 3.84. Into 10 power minus 14. 3.84 into 10 power minus 14 Newton. This is first part. Second part is calculate the acceleration. Acceleration is A is equal to force by mass. Force is 3.84 into 10 power minus 14. What is mass here? Given 6.65 into 10 power minus 27 kilogram. Given. So 5.77 into 10 power 12 meters per second square. Actually 10 power minus 14 plus 27, 10 power 13 will come. 0.577 you will get. So 5.77 10 power 12. Acceleration, not velocity, acceleration. So next problem, ninth one. An electron moving northwards with a velocity of 10 power 7 meter per second in a magnetic field of 3 Tesla directed eastwards. Calculate the instantaneous force acting on the electron. Straight problem. F is equal to BQB sin theta. BQB theta. What is B? 3 Tesla. Charge 1.6 10 power minus 19 coulomb. Velocity 10 power 7 meter per second. Theta moving perpendicular 90. Therefore, F is equal to 3 into 1.6 10 power minus 19 into 10 power 7 into 1. 4.8 into 10 power minus 12 Newton. Direction. Eastward means upwards. Fleming's left-hand ruler. Forefinger eastwards. Thumb direction of force. That's all. So this is eastwards. This thumb represents upward direction. 10th problem. An electron is moving at 10 power 6 meter per second in a direction parallel to a current carrying conductor of 5 ampere current flowing through a straight wire perpendicular to a distance of 10 centimeter in air. Calculate the magnitude of force experienced. See here directly force is not asked. Current carrying conductor, current is given, distance is given. So you have to calculate the magnetic field. Using Biot-Savart law, magnetic field due to infinitely long charged wire, infinitely long charged conductor, you will get mu naught I by 2 pi r or 2 pi d, whatever it is. Mu naught value 4 pi into 10 power minus 7. Current 5 ampere, 2 pi into place at a distance, perpendicular distance of 10 centimeter, that is 0.1 meter. 2 times 2 into 5, 10. 0.1 and 10 means 100 times. So 10 power minus 5 Tesla. So from the calculation, we are getting the answer 10 power minus 5 Tesla. Now you calculate the force. Therefore, F is equal to BQV sin theta. BQV theta. B is 10 power minus 5 Tesla. Charge, electron 1.6 10 power minus 19 coulomb. Velocity 10 power 6 meter per second. Theta moving perpendicular 90. Therefore, F is equal to B 10 power minus 5 Q 1.6 10 power minus 19. Velocity 10 power 6 sin 91. 1.6 into 10 power minus 5 minus 19 is minus 24 plus 6 10 power minus 18 Newton. 1.6 into 10 power minus 18 Newton. Okay. So magnetic Lorentz force, whenever a charged particle plays an uniform magnetic field, what is the force experienced by the charged particle? That is the basic formula, basic concept we have seen. Then based on that magnetic Lorentz force, this is the thing. Some cases, if electric field is also applied, what will happen to the force? That also possible. What? You are applying electric field also. General formula Q into V cross B. If electric field E also applied, then F is equal to Q into B cross B plus E. Because the F is equal to EQ. So you have to take E value also in that case. Magnetic field alone means no problem. Okay. So this is magnetic Lorentz force. Based on that, we have done the problems. We have done few problems. Thank you.